Gonna lie, I went through and I did 8 through 13.
Okay.
I love doing the easy things first, and those are super easy, so I felt super smart. I'm like pathetic when it comes to that. I'm like, I'm smart, I can do this.
Hey, you got to be your own cheerleader. That's good.
I know.
Okay, so I have the R factor would be 0.901.
That's what I've got.
Other corner.
What does it mean your answer should be exact?
Well, probably the 0.901 instead of like saying just 1 or close to 1. I would guess. My 0.901 has 2 little asterisks by it. Does yours?
Yeah. Okay, so tell me. Now wait a second. Oh, okay. All right. Yeah, 0.901. And I have the covariance is 0.901.
So the covariance is 0.90, I mean the correlation coefficient is 0.901.
Yes.
Okay, that's what I thought. That's what I got, but I don't usually do it in Excel, and I didn't in Excel this time.
Okay, so I have 13.981.
As your answer?
For the covariance.
Okay, I'm still multiplying mine, so hold on. But what did you multiply? Because one of my standard deviations is 13.595.
Yeah.
Okay.
Look in the Lazy Susan. Babe, Lazy Susan. The Lazy Susan over there. There should be some oil in it. Or it's in.
Okay, what did you say
cabinet.
you got, Lori?
13.981.
Okay, yeah, I got 13.9811170.3, and we're just rounding it to 1, right?
Yeah.
Okay, that's what I got.
1 decimal point. So it's 14 then, right?
I think so. That's what they've done on all the examples is they've rounded it to the whole number.
That means if it's rounded to 1 decimal place, it's just going to be 14.0.
Yeah.
Okay. All right. Are we ready?
Yep.
Okay. Well, I mean, the next ones aren't going to take too long because they're pretty easy.
Okay, so number 8 would be C.
Mm-hmm. Number 9 should be A.
Number 9 is A. Yep, I agree with that.
10 should be D.
Yep, I agree with that.
11 should be B.
Would be B.
Mm-hmm. 12 should be E.
12 should be E.
And 13 should be F. All right.
Correlation. Oh, here we go, back to SPSS.
So the math self-efficiency, I'm going to have to go look for that. Which one is it called again? Math self-efficiency.
What are we looking for?
Yeah, what are we looking for?
So with that one,
between score and confidence.
Well, yeah. Oh, that's right. I didn't see that part.
Okay.
Man, we are popular today.
Okay, so this is kind of a moderately strong thing. Positive.
Yes.
Okay.
Come here, Blue. Come here. Come here, bud.
That is Michael.
Okay, so I have 0.728.
Yeah, that's what I got for the.
I've never even shot paintball guns, so how should I do that?
I have a paintball gun. It's not from my brother. It's one of the best there is.
We need to go.
Yeah.
Okay, sorry. I'm distracted. Stop distracting me.
Sorry.
Mm-hmm.
Okay, and then I got 11.1842.
Yep, that's what I got too.
And now, see, this one says round two, two
Be 11.
decimals.
11.19.
No,
No.
11.18.
Oh, you're right, because it's 4. Duh, I knew that. Wow.
And did we double?
2, 0.
Can we go over 14? I just want to make sure that I did the process right.
Are you in SPSS?
No, I'm in Excel.
I don't know how to do it in Excel. I only know SPSS.
No, I know, like, I want to make sure that my answer's right, because I just finished the process.
What'd you get?
I got 0.842.
No, 0.728
Yeah, that's what I got.
is what I got.
Okay. I'll go back and I'll do it in SPSS. Like, my notes are for SPSS. I don't even know why I'm doing it in Excel.
Wow, I just rechecked my answer and got a completely different answer.
For that
Okay.
one,
Sorry, guys.
Let me recheck mine.
for covariance or correlation?
Okay, and there I got my original. Okay, I'm good. Sorry, just double checking.
I'm just going to double check too.
Hey, we like double checking.
Okay, yeah, I still got 11.1842358. So,
Yeah, me too.
Okay.
Oh, that's what I did. Okay. I figured out what I did wrong.
All right.
Okay, and we're good with all the other answers?
Yeah?
Yeah, do you want to
Susan,
go
do you
through
have
it again?
I think I'm good. I'm looking at them again. I think we've got it.
Yeah,
Okay.
this one actually wasn't too bad.
Sounds good to me.
Woohoo! Oh, wait, what? Oh. I was wrong. The other variable tends to decrease.
Oh, really?
Mm-hmm. Oh, that's right, because it... Ow. I got it confused.
All right, I'm going to write that down in my notes.
Yeah. Because when x will increase, y has to decrease. Otherwise, it would just be a straight line. Like a flat line. Okay, that makes sense.
Yeah,
Well,
I guess.
that was
yeah,
my
I guess
that was
you're
my
right.
stupid mess up. Yeah.
Well,
Okay.
we all okayed it.
Well, we all have those days. All right. So, do we have any questions about the project?
Yeah, we need
Yeah.
to talk.
Yeah, we've got to figure out how we're gonna describe the data.
Yeah,
So, who's in charge of this part for this week?
Lori is.
I think I am, right?
Okay. I
Uh-huh.
think I'm 5 or 4, one of them, like that.
Yeah, it says in no more than 2 pages, describe the data you collected. I'm like,
I love it when they say no more than 2. It's like
when I saw that, I'm like, it's gonna take.
want more than 2 pages. Describe it. Well, because I think what she's asking is to describe the data, because the data that we were getting is going to be different because it's bag by bag.
Well, and
so,
we have to send graphs in and everything too. So
I'm really glad I'm not doing that part. I hate making graphs.
All right, so
okay, so just tell me. So we all have a list of six plain and 6 peanut, right?
Right.
mhm. Yep.
Okay, so
You want our numbers?
Yeah, do you need me to email you my
yeah, I need you to email me your numbers, but then how do I
compute that?
yeah, so when I put it in SPSS, are we gonna do an ANOVA test? Is that what we're doing?
I would think so because we have
yeah.
4 people.
Yeah.
Yeah,
Yeah, that
so
makes more sense.
so what
And there's
I
6
do
separate sections.
so what I do is I put like Susan and then red, yellow, blue, green, brown, orange, and then Lori, red, yellow, blue, green, right?
Yeah.
I think
And I do it like that, right? Okay. And then I just do an ANOVA test.
so. That's what I would do. And
Okay, but
didn't we say in our statement that it would be from different parts of the country? So do we want to add that in, or is that in the next part?
oh, like do Lori, Wisconsin.
Right.
Okay.
Yeah.
Yeah, maybe we should do that.
So I didn't buy mine in Idaho. Mine were bought in Utah, but
That's all right.
we'll count. It's only a state over.
So Stephanie is in Atlanta.
Mhm.
Susan is in
Corey, Pennsylvania. Corry, Pennsylvania.
and then Abigail.
I am in Rexburg, Idaho.
Okay, but our question states, and this is when I was looking at this last night, our question states that we're going to compare the red plain to the red peanut, right?
Mhm.
Okay,
Yeah.
so
Oh, I compared them all.
So
So-
if we do an ANOVA test,
Okay, well, yeah, then we can't do an ANOVA test because we're only comparing 2 things.
So would that be paired samples but independent?
Yeah, I think so.
Yeah, that sounds like
Hey.
it's an independent paired sample.
that's what I was wondering. But with an ANOVA test, you can do 2+ groups.
Does she want us to do it with more than just one color or just the one color?
Now wait, an ANOVA test,
Let me see.
you know what? You're thinking a chi test.
Ow!
We were thinking a chi test when we said, right, Susan, Lori, Stephanie, and Abigail with red, yellow, blue, green, orange, brown.
Mhm.
That's a chi test, right?
I think so.
Yeah.
Hold on, let me.
So are we just going to put each person is assigned to a color?
No.
No.
Okay.
So we've got to go back to an ANOVA test.
All right, let's look.
So that would be lesson 14.
Babe, that smells so good. It's ridiculous.
Okay.
No, our research question, are the distribution of colors between the plain and peanut M&Ms equal?
With each color.
Yes.
That's
So is it equal with red, equal with orange, equal with yellow?
Mhm.
was the distribution equal between the plain and the peanut?
Okay, then it is an ANOVA test because then our hypothesis is going to be all of the means are equal, and the alternative hypothesis is one or more of the means differs than the others.
Yes, that's perfect. Okay.
Okay.
That makes more sense to me because I'm like, okay, I think we had it right in our heads and then we did a chi-test.
Right.
Or we set it up like a chi-test. Okay, so how we set this up then is we go to our SPSS chart.
Mm-hmm.
And I'm going to put in new data.
Mm-hmm.
So I definitely need all of your things.
Yes, you will.
And I'm going to put in, like in the variable view, I'm going to put in plain M&Ms. Oh, an illegal character.
Okay, hold on. I'm trying to think this.
Look, I'm not sure. Okay. Oh, I probably don't because I took the
Okay, so you're going to put in the plain plain red M&Ms from all of us, right?
No, I think I list them separately underneath plain M&Ms. Then I put under plain M&Ms I have to put red, yellow, or I'm just setting it up to try to test it.
Okay, okay.
Red, yellow, orange, blue, green, and brown. Oh shoot, what'd I do? Okay, Susan, read our question one more time.
Let's see. You want the design the study question?
Yeah.
All right, it says, are the distribution of colors between plain and peanut M&Ms equal in a 3-pound bag of plain M&Ms and a 3-pound bag of peanut M&Ms packaged and distributed by the Mars Company?
Okay, so answer me this. Do we take all of our reds and combine them, and all of our for plain and all of our reds for peanuts and combine them?
That's what I think we have to do if we're going to do an ANOVA test. Because, yeah, I think that's what we're supposed to do. Okay, but I'm looking at our paper that we turned in, and our null and alternative hypothesis was mu D equals to 0 and mu D not equal to 0. Is that still the... That's not the ANOVA hypothesis, not ANOVA test.
No, that's a difference. That's the two means paired data.
Yeah.
That makes more sense, right?
Yeah. Because I think we have to combine, because we said all the plain and all the peanut. So I think we have to combine our numbers.
Yeah, I think so too.
Well,
Susan, we can't hear you.
hang on. Let me invite her again.
Okay, that makes more sense to me. That
Mhm.
makes more sense.
Yeah, I
Because as
think
I
that's
see, yeah, as I just put my numbers in here,
Mhm.
then we can run the difference of the colors. Okay, now, should I run a test with the difference of each 4 of ours?
I think that would be kind of good.
Yeah, I think so too.
Agreed.
Oh, Susan says her computer just went back. She's trying to sign in again.
Okay.
Okay, so what I'm going to do is all of you send me your data as quick as you
Yeah.
can, and I'm going to
Okay.
put it in an SPSS form, and
Okay.
then we'll work on it on Thursday.
Yeah, I think that's a great idea.
But yeah, thank you for looking at that sheet again, because you're right. We already decided what test we were going to do.
Mhm. Yeah. Yeah.
But I'm wondering,
Okay, but now listen, now the next question, it says, what populations are you studying? And we said, how many of each individual colors, red, green, orange, yellow, brown, and blue, are in a 3-pound bag of plain M&Ms and a 3-pound bag of peanut M&Ms? So, do we have to leave them in our 4 groups?
well, that's what I said. Do we? I think maybe we do.
I think that's what we stated that we would do. So,
Yeah. So then if we have them all in those 4 groups, how do we come to a single answer for each color? Because that's what we eventually have to do, right? Is come to a single answer for each color.
I think
Right?
so. Yeah, because then on number 6 we said each sample will be purchased from 4 separate stores from around the United States, specifically Georgia, Idaho, Wisconsin, and Pennsylvania. So I think we do have to put them all together in the end and come up with a list. All the orange, all the red, all the, you know.
Okay, so I'll list them individually, and then I'll also list them, like maybe what I'll do is do a graph of each one separately, and then combine them and do a graph of all of them combined.
I think that's a great idea.
Yeah, that sounds like a really good idea.
Does that make sense?
Yeah.
Yeah.
Does.
Okay, so I'll list the data separately, and then I'll do a graph separately, and then I'll combine everything. Combine the data and combine the graph.
Yeah, I think that's a great idea, Lori.
But really, I think the only thing she needs is that last one. I mean,
I know, but I think the more information we can put on there, the better it will be.
Oh yeah. To get that less than 2 pages.
Yeah.
Okay. Let's see. Yeah, I think that will totally work.
Okay. All right.
Yeah, it looks like we've covered them. So if you can send me that data, because I have a free night tonight and tomorrow, so if you can send that to me right now, that would
send
be
it to you
great.
right now.
I sent mine to you a couple minutes ago, so you have mine.
Okay, perfect.
And I just sent it.
Yeah, and then I'll get it, and then I'll send it all back to you when I get it done before next week's or before Thursday's meeting.
Okay, and then, yeah, if we can get that done and then maybe be looking over next week, because I have a really busy week next week, and it's mine and Abigail's next week. So if we can start turning that,
if we can get a head start on that, that'd be fantastic.
Yeah, because that is, I'm right there with you.
Yeah, because
I'm just making sure. Okay, yep, it looks, I just don't have yours, Susan.
Okay, I'll send it.
I'm just making sure I got yours. All right, Abigail, I have yours. Okay, and Stephanie, I have yours too.
Okay, perfect.
Okay. Okay. All right, then Susan, if you'll send me yours, then we'll see you on Thursday.
Okay, sounds good.
All
Thanks,
right.
you guys.
Thank you. Bye.
Bye.
Bye.